absolute, same thing. Max can or cannot be found at an endpoint.
It can.
Yes, of course. It can, of course. An absolute or global max can be found in the middle, or it can also found at the endpoint. Which one cannot be found at the endpoint?
Relative.
Yes. So the local and relative, in other words, not. This is what cannot be at the endpoints. A local max or min cannot be found at the at any endpoint. Okay. A critical number comes from ... sources.
F prime equals 0.
Yes, so you're saying two sources. Yes, f prime equals 0.
And F prime is undefined.
Yes. Where f of x is defined. So it's not sufficient. I'm not saying it's, I'm just re-emphasizing. So it's not sufficient to say that f prime is undefined. No, we have to say that f prime is undefined where f of x is defined. Because if f of x is undefined and the derivative is undefined, then that's not a critical number. But f prime is undefined where f of x is defined, that is a critical number. Okay, number 3. A critical number always represents a max min. True or false?
False.
Of course. It is false. Other things have to be checked and other things have to happen for a critical number to be a max or a min. Awesome. A function can or cannot have a max min where it is not differentiable.
Cannot.
So one more time. A function can or cannot have a max min where it is not differentiable.
It can, like an absolute?
It can. Because the function, for example, can have a cusp. At this point, the function is not differentiable, but it has, the way I graphed it, it has an absolute min and a local min. So make sure you understand that even if the function is not differentiable at this point, so we basically have this situation. So the first derivative is undefined, but the function is defined. So that's exactly what it is. At this point, f prime is undefined, but the function value exists. Okay, so
Can I ask a question about local
I'm sorry?
maxes and min? Can I ask a question about local maxes
Yes,
and mins?
yes.
Is that only going to be when we are given an interval? Or is it going to be, can you just say like any function where it's a local max or min? Okay, because that's the only place where it has inflection points.
But it can look like this. It doesn't have to have an inflection point.
Okay.
It still will have a local min, or it will have a local max. So the inflection points have nothing to do with the max min. The function can still have a max without having inflection points. Is that clear?
Yes, because inflection points only come from the regular, not the derivative.
They come from the second derivative. We haven't talked about that yet.
Oh, sorry.
No. I love it when my students are way ahead of me. So the inflection point that you're talking about will be discussed when we get to today, when we get to the second derivative. I promise. We can move on without that. Other questions? Okay. So is this clear? So a function can have a max or a min where it is not differentiable. And this is the example. And this is the situation. It's part B here. Okay, perfect. Moving on. Number 5. A function has a max if the derivative function is or, and the derivative function dot 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 sine from this to this. So let's do this again. A function has a max. I picked max, it doesn't matter. Let's stick with max. If the derivative function is or this,
Increasing.
0, 0, or
Undefined.
yes. Of course, where f of x is defined, because we are talking about a max. Otherwise, it would not have a max, so that's clear. And the derivative function,
Changes.
yes, sine from exactly specifically because I picked max. From
Positive to negative.
yes, from positive to negative. Awesome. Awesome.
Can you explain the positive and negative part real quick?
Sure.
Oh, okay.
So it could be positive 0 negative, or it could be positive undefined negative. And that's for the local max. Perfect. Is that okay? If a function does not have critical numbers, it does
Not have them in.
exactly, of course. It cannot have. If it does not have critical numbers, it does not. But if it has critical numbers, is there a guarantee that it has a max min?
No.
No, because the derivative has to change sign from blah to blah, either positive to negative or negative to positive. If it does not change sign, there is no max min. Awesome. And I think I have these two, and that's it. Yes. 7. Rolle's theorem has ... hypothesis.
3.
Yes. The first one is
F of x is continuous on A and B, or A to B.
closed. Yes.
F of x is differential on closed A to B.
This is the closed, this is the open, because we don't care if it's differentiable at those points. So this is closed, and this is open.
And the F of A is equal to F of B.
Very good. And then remember, there is always at least one C between A and B, such that f prime of C is 0. Last one here. First derivative gives us a lot of info about the function. What does it give?
Critical numbers.
Yes.
Gives us the max and the min.
Under
And,
certain conditions. Yes.
Under certain conditions, and then intervals of increasing or decreasing.
Very good. Increasing, decreasing intervals. Awesome. Brilliant. Great job. That's all I had to say. So now the floor is yours, and then we move on.
Can we do number 10 from 4.1 Web assign?
The answer is always yes.
All right, so it's f of t. Sorry, the question is find absolute max and absolute min values of f on the given interval. Function is f of t equals, in parentheses, t squared minus 9 cubed. And the interval is -3, 5.
I'm just checking my memory. When you get to my age, you will do that too. Do we still need to do it?
No, I'll double check. I felt good about my answers, but
Let's see. No, if there is any doubt about the answers, let's do it. So f prime of t, bring down 3, t squared minus 9 to the second power times the inner function prime, which is 2t. We said it's equal to 0, right? So I don't want to do that, so I'm just going to write an arrow. So f prime of t, because it's never undefined. So we get basically 3 solutions, right? Because this factors into t minus 3, t plus 3, and squared, and then t. So we will have 4 solutions from here and 1 solution from here. But 2 of them are the same. T equals 3, t equals negative 3, and t equals 0. So I will get my table going right away. F prime of t, f of t. And I have to put just this interval. Please do not put negative infinity to infinity. That's not correct. And I have to put in these 3 values. So I see the 0 is here, the 3 is 0, 3 and 0 are here. And then I also see negative 3, so that's a 0 here. Good. At this point, I have to study the sign of the derivative. And then I have to plug in these numbers in the function, because we are talking about the function. So in t squared minus 9 cubed, I have to plug in negative 3, 0, 3, and 5. So let's do that. I'm sharing my screen. I'll go to this. I'll put in there first the function. So we have t squared minus 9 squared, cubed, sorry, cubed. And I also want to put the derivative in there, which is 6t. And in parentheses, t squared minus 9. I'm checking again, so 6t correct, t squared minus 9 correct, squared. Good. And t squared minus 9 cubed. Okay, so now for the derivative, which is the second one, I need to plug in, so let me stop sharing for a second. For the derivative, you don't have to put them in the table. For the derivative, I'm going to plug in negative 2. Although there is no need, really, because this is always positive, right? So 2t or t is negative to the left of 0, and it's positive to the right of 0. So I shouldn't even need to do anything. I covered the 3, the t squared minus 9 squared, and also the 2. So the sign is really given by t. To the left of 0, t is negative. To the right of 0, t is positive. So I really don't need the first derivative. But I do need to plug in the function these values and see what I get. I can see already what I get because this is 9 minus 9 in both situations, so this will be 0. And 0 minus 9 is negative 9, and negative 9 to the third, what is it? 81 times 9, 729, and negative, of course. And when I plug in 5, this is 25 minus 9. I have to square. Remember, last time I didn't square. So 25 minus 9 is 16. 16 to the third. I don't know what 16 to the third is. 16 to the third. 4096. So it was basically too easy to even use the calculator. So all the numbers are here. Now I have to make sure, because that's how I catch my mistakes. This is the moment of truth. No one needs to tell me whether I have an error or not. If these 2 rows do not work well together, then I'll say, oops, I did something. So from 0 to negative, yes, that's correct. From negative 729 to 0, yes, that's correct. And from 0 to 4096, that's correct. So I know now that these 2 are in sync, unless I plugged in something incorrectly, but everything else should be correct.
Can I ask a question?
Yes, of course, any question.
So when you put in the t values on the very top row, I know they give you an interval from negative 3 to 5, but all the numbers in between, it doesn't really matter which ones you pick.
Oh my goodness, no. The critical numbers.
Okay.
Critical numbers only. So this is here, this is here, this is here. I will never, now if you're discussing points here, values here, I could use those between these two to find the sign. Between 0 and 3, I will plug in 1 to find the sign. Between 3 and 5, I will plug in 4 to find the sign. Between these two, I will plug in -2 to find the sign. But those do not belong in the table. I use them to find the sign. But the table has only critical numbers. That's why f prime is 0 under -3. F prime is 0 under 0. And f prime is 0 under 3.
Okay.
Better?
Yes.
Awesome. Thank you. Other questions? Anyone? It can be confusing because I also talk with you about two different things, right? First of all, the critical numbers, and then numbers in between to find the sign. So try to understand the difference between the two. Good. Next question, please. Anything? Was this okay?
Yeah, Professor, I literally wrote the maximum in the minimum and the minimum in a maximum. So of course.
Okay, so now we have to make a decision. And here's how we make the decision. Unless you didn't square the 3 like I did, like I forgot last time, you're fine. So obviously, this is the altitude 0. This is the altitude -729. This is again altitude 0. And this is the altitude 4096. I'm not graphing the function. I'm just showing what's happening here. So this is definitely the absolute minimum. It's also a relative because it's not at the end point. This one is only the absolute max. It's not a relative because it's the end point of the interval. And this is nothing because it's not the biggest or the lowest, and it cannot be a local. This one is nothing because, as you see, the derivative does not change sign. So this is negative, this is positive. So obviously this is the absolute minimum or relative minimum. But here there is no sign change. So 3, 0 is nothing.
Yeah, this was an English problem. I read it the wrong way and put
No
the answers in the
worries.
wrong spot.
No worries.
Thank you.
English